Okay, number 31 here. To do this problem, you've got to go back and you got to remember a decent amount of stuff from back in chapter 3. We're asked to evaluate a definite integral from pi over 20 to pi over 10 of cosecant 5x times cotangent to 5x, all taken with respect to x. So the first thing we want to do, guys, this is a fundamental and basic idea that's really easy to lose track of, is that in every integral we're asked to evaluate here in chapter 5, when it comes time to antidifferentiate, the first thing you want to ask yourself is, do I recognize this integrand as a derivative from back in chapter 1? And the answer to that is kind of. You guys learned back in chapter 1 that the derivative taken with respect to x of, and here we go, this is most closely related to the derivative of cosecant of some angle u. And the derivative of cosecant is the opposite of cosecant of the same angle, u, times cotangent of the same angle, u, and then multiplied by the derivative of u taken with respect to x. So what we have right here, guys, is a true statement. Now what I could do, though, is, well, first I should notice this integrand right there is positive and not negative. So what I could really do is just divide both sides by -1. And here's what that really does. Let me undo that. What that really does for me then, guys, oh, I broke it. What happened there? All right, so that shouldn't be there anymore. All right, basically I can take the opposite of both sides, which will turn this right side positive, and then that negative is going to go right there. So we're on to something here, guys. This integral right here is the derivative of the opposite of the cosecant of the same angle, which is going to be a 5x. The only problem, though, guys, is this thing right here. When we go to take the derivative of a negative cosecant of 5x, it would be positive cosecant of 5x times positive cotangent of 5x, but then times the derivative of that angle, which would be 5. There's no 5 out here, guys, so to undo that, we're going to have to divide this by 5. So watch this little trick. I'm going to turn that negative into a fraction, 1/5, and then I'll put a negative out in front of that. All right, and so now when you do go to take the derivative of 5x and there's a times 5 at the end, that cancels out with that 1/5 right there. So that's what we've got for our antiderivative. That's a tricky one, but it's correct. Now, because it was a definite integral, we put the evaluation bar at the end and a pi over 20 for the lower limit and a pi over 10 for the upper limit. Now, if those angles scared you a little bit because they're not angles that you recognize, you're right about that, but remember, each of those angles needs to be multiplied by 5. Now, what I would do here to evaluate this is take the -1/5 and just leave it out in front, and then start a set of brackets, and let's just focus on what's going on right here. This now becomes the cosecant of 5 times pi over 10. So that's going to be 5 pi over 10, or pi over 2, minus cosecant now of 5 times pi over 20. 5 pi over 20 is going to be pi over 4. So that's what this evaluation would look like here so far. So let's keep going. -1/5 times, and here we go, cosecant at pi over 2. Just in case we've forgotten any of this stuff, pi over 2 is straight up where your sine or y value is equal to 1. Cosecant is the reciprocal of sine, and lucky for us, the reciprocal of 1 is 1. Minus, all right, cosecant at pi over 4. Pi over 4 is right over here, where sine is equal to 1 over root 2. It's also equal to root 2 over 2 if you wanted to rationalize that, but I want cosecant, which is the reciprocal of this number, so that is just a root 2. Okay, and then from there, you guys, not that much happens. I think at this point I can probably get rid of all of that and say, all right, I actually wouldn't mind if you guys quit right there. If you can't combine the two terms in the brackets, they're not like terms, one's rational, one's irrational, I guess if you wanted, you could distribute the -1/5 and make that a -1/5 and then plus root 2 over 5. And then I suppose if you wanted, you already have a common denominator, maybe that would be more nicely written as root 2 minus 1 all over 5. But I would actually be okay with any of these three versions of the answer right here. I kind of think this one right there is maybe the prettiest and simplest out of them, but as I'm looking at the solutions manual, they pretty much left it here. The exception that they did, I see this now, guys, is they said, all right, let's distribute just the negative inside there. So they wrote that as, let me clean this out right here, they wrote this as a positive 1/5, and then in brackets, it would have been a negative 1 plus root 2, which they now flipped around and wrote as root 2 minus 1. So, okay, I guess that's a fourth version of this answer that could have been right. I still think that this one right here is the prettiest. That's the answer that they came up with. But you guys know at this level, you really don't have to simplify your answers. That's a grading tenet of the AP test we're going to try to get used to. So any one of those 1, 2, 3, 4 versions that I have there all would have worked out okay and gotten you full credit for number 31.